In this video, we will be talking about algebraic fractions. In general, there are two different kinds of algebraic fractions. There's algebraic ratios and algebraic proportions. Ratios are a little bit easier to deal with because they're just simplification. You only have one expression that you're trying to simplify down to its simplest form. Algebraic proportions are a little bit more difficult because you're actually solving for a variable. So you do have an equal sign and then two or more expressions to deal with. So first we'll do algebraic ratios and then we'll move on to algebraic proportions. We're asked to simplify 3x squared minus 12 over 6x squared plus 12x. And when we're dealing with algebraic ratios and proportions, we're going to want to deal with the numerators and denominators independently first, and then bring them together and see if we can cancel anything between the numerator and denominator. And the reason for this is just because it helps to simplify them separately, just to keep everything straight, both on the paper and in your mind. So first things first, write down the problem, just so you make sure that you have all of the information correct. So you have 3x squared minus 12 all over 6x squared plus 12x. And then let's do the numerator first. And when I say first, I don't mean that we're not going to write anything down. We're going to write down all the information every time, but we're just going to try to figure out stuff for the numerator first and then the denominator, etc. So first we have 3x squared minus 12. What you're going to do is look for some term that is common between both the 3x squared and the negative 12. And pretty quickly we can see that there's going to be a 3 in common. If we factor out a 3, 3x squared divided by 3 is just x squared. Negative 12 divided by 3 is negative 4. Now we can look at the denominator. We have 6x squared and a 12x. Right away we can see that there's a 6 in common, but there's also an x in common. So you're going to write down as many common terms as you can, basically looking for the GCF, or the greatest common factor of our terms. If we factor out a 6x from 6x squared, we're left with just an x. And if we factor a 6x out of 12x, we get positive 2. Now we can continue. Let's look at the numerator again. We have 3 times quantity x squared minus 4. When you get better at factoring, you should be able to see quickly that x squared minus 4 can quickly factor into x plus 2, x minus 2. And that's just something you'll get better with that as you practice. The denominator is as factors as it's going to get, so you can just rewrite it as 6x times x plus 2. A good way to kind of check to see if you're simplified all the way or factored all the way is that if your terms are all of degree 1, so there's just x, there's no x squareds or x cubes or x to the anything, then there's a pretty good indicator that you're pretty much factored all the way that you can go. So now our numerators and our denominator are independently done as much as they can be. So now we can start looking at them together. If we look at everything not in parentheses, 3 over 6x, we can have a 3 cancel out of both of those, giving us 1 over 2x, and then still times x plus 2, x minus 2, and then times x plus 2. And then that was taking this and making that 1, and this making this 2x. And now we can see that both the numerator and the denominator have an x plus 2 in common, so we can cancel that, giving us x minus 2 over 2x. This is a fine answer. You can leave it like that way, or you can break it up into its two elements, giving us x over 2x minus 2 over 2x, and we just broke it at this negative sign there. Now we can do some simplification, canceling an x, giving us 1 over 2, and here canceling the 2's, giving us 1 over x. So here are two different solutions, but they're equivalent, and they're both completely fine for your final solution. Next, let's move on to algebraic proportions. Algebraic proportions are essentially the same concepts. The only thing is that you're going to be using cross multiplication, and you're actually solving for a variable. In case you don't remember what cross multiplication is, if something is in the form a over b equals c over d, we can cross multiply across the diagonals, which will give us a times d equals b over c. So if we use that concept, we have this cross and this cross, so we can cross multiply, giving us 4 times x plus 3 equals 7 times x minus 2, and we cross multiply it immediately. First of all, because there's really nothing we can do to the numerators or denominators separately, and also when you're dealing with a equation, getting rid of the fractions is probably one of the first things you're going to want to do because it makes simplification a lot easier. If we use distributive rule, we can distribute the 4 across the x plus 3 and the 7 across the x minus 2, giving us 4x plus 12 equals 7x minus 14. And now we need to solve for x, which means we need to get x all by itself on one side of the equal sign and everything else on the other side. We can do that by subtracting 4x from both sides, or 7x from both sides. It doesn't matter. It should give you the same answer in the end. This will give us 12 equals 3x minus 14. And now we need to get this negative 14 away, which we can do by adding 14 to both sides. And if we take it over here, it's going to get 26 equals 3x plus 0, which we don't have to write. So we have all the x's on one side and the constants on the other. So all we have to do is get this x to be 1x instead of 3x, which we can do by dividing both sides by 3, giving us 26 over 3 equals x, which is our final solution. Lastly, we're asked to solve x squared plus 4x plus 4 over 2x minus 1 equaling x plus 2 over 1. First things first, we can cross multiply, which is going to give us x squared plus 4x plus 4 times 1 from this cross equals x plus 2 times 2x minus 1 from that cross. And now what we can do is let's expand the right hand side. We see that x times 2x from FOIL is 2x squared, and then we have FOIL, we've done FOIL, F. Now we need to do the O, which is the outer, so x times negative 1 is negative x. Inner, 2 times 2x is plus 4x. And last, 2 times negative 1 is negative 2. With some simplification, we see that gives us 2x squared plus 3x minus 2 equals x squared plus 4x plus 4. We can write that down quickly. Since we're solving for x, we need to get all of our x's to one side and all of our variables to the other. However, as you can see, since we have a quadratic term, this should kind of put a red flag up and say we're probably going to be using the quadratic equation eventually, or some sort of factoring. So let's try to get this all combined into one term, or not term, but one expression equaling 0. We can do that by subtracting the right-hand side from both sides. So we're going to subtract 2x squared minus 3x minus 2 from both sides. Excuse me. Okay, which gives us x squared plus 4x plus 4 minus 2x squared minus 3x plus 2, since we brought it across the equal sign, equals 0. From there we can simplify. So we have our x squared terms, our x terms, and our constants. X squared minus 2x squared is minus x squared. 4x minus 3x is plus x. And positive 4 plus 2 is plus 6 equals 0. If we multiply everything by negative 1 to get rid of this negative sign, this gives us x squared minus x minus 6 equals 0. And you don't need to do that, but we usually like to try to make it so that the quadratic term is always positive, just because it makes factoring a lot easier. Now you can go about this by two ways. You can do the quadratic formula and solve for x that way, or you can just look at this and realize that this is a factor pair of x minus 3 and x plus 2, which gives us our solution x minus 3 equals 0 and x plus 2 equals 0, which means x equals 3 and negative 2, which are our two solutions for this expression, for this algebraic proportion.